Hello, I'm Vikas Bhatia, and I lead product for Azure Compute Security and Confidential Computing at Microsoft. Today's session is about a partnership that's redefining what's possible in the cloud security. Our partnership with AMD, Intel, NVIDIA, and various other ecosystem players working together to bring hardware rooted confidential computing to sovereign and regulated workloads. In the next few minutes, I'll walk you through the security foundations and the latest innovations along with real world customer impact. Here's the roadmap for our session. We'll start off with talking about Azure's Security and Confidential Computing Foundation, what it is and why it matters. Then we'll move into digital sovereignty, which is top of mind for governments and regulated industries worldwide. And we'll close with a few real world customer use cases showing how organizations are already running on this technology today. So, this is our first section, Azure Security and Confidential Computing. Everything we talk about builds on the security architecture you see here. The key idea is that security has to start in hardware, not on software. Microsoft's Secure Future initiative is the company-wide mandate that puts security first in every product and every engineering decision. It's organized around these three pillars: secure by design, secure by default, and secure operations. Amongst all the efforts happening in Azure and Microsoft, confidential computing is one of the key initiatives that sits at the heart of this effort. It's not a feature that we bolted on, it's a design principle embedded across Azure. So, this is what Azure's hardware security architecture looks like: multiple layers, each reinforcing the other. The hardware based on root of trust, anchored in silicon, powers our confidential computing with hardware based trusted execution environments or TEEs. We've also worked with our industry partners to enable Calyptra, which gives us an open source silicon root of trust. Azure Boost, a purpose built FPGA, isolates all infrastructure management onto dedicated hardware, and our latest innovation, Azure Integrated HSM, protects cryptographic keys at FIPS 140-3 Level 3 assurance. Security isn't just one lock on the door, it's defense in depth, and every layer here is anchored in silicon. Starting with Azure Boost. Azure Boost is Microsoft's purpose-built hardware system for infrastructure offload. It moves networking, storage, and host management off the main CPU onto dedicated silicon. So, why does this matter for confidential computing? Because it creates a clean separation between Azure's management plane and your workloads. Boost manages the infrastructure. Your confidential VM and containers remain untouched and isolated. So the key takeaway here is Azure Boost is the engine underneath confidential computing. It's what lets us deliver both strong isolation and high performance at the same time. The next innovation is Azure's next generation integrated HSM. We announced this at Ignite 2024 as part of our Secure Future initiative. This is a major leap forward in hardware rooted key protection and is designed from the ground up. Let me highlight what makes this significant. First, it's ready with native CNSA 2.0 cryptographic support, meaning that your keys are protected against both classic and future quantum attacks. Secondly, our open source hardware root of trust with continuous attestation, so you can verify the HSM's integrity at any time. And third, the HSM sits locally on every server node, which eliminates the latency of centralized HSM round trips. That kind of throughput matters when you're running key operations at scale across your VMs, Azure Key Vault, TLS termination, and fleet-wide crypto acceleration. I'm happy to announce that we have made this capability generally available on the latest generation AMD architecture, and these will be available in all future hardware systems that we deploy. Now that we talked about our hardware innovations, let's talk about isolation. There are two guarantees on this slide. One, the cloud provider isolation. Your VMs are protected from the host platform in the control plane and from us as the cloud operator. Second, tenant isolation. Your VMs are protected from every other tenant running on the same server. Along with other assurances, Azure's work here ensures that the CPU itself enforces these boundaries, not the hypervisor, not the software, but the hardware. By protecting data in use along with existing protections, your data and code stay private, even from Microsoft. Now that I showed you the tenant isolation as well as the cloud provider isolation, this talks a little bit more about what you can do with the platform. We have capabilities from a hardware platform root of trust with Azure Boost and integrated HSM, through verified boot chains with trusted launch, all the way up to AKS security controls and just-in-time VM access. The point here is security is built into every layer of Azure, right from the start. So now let's dig into confidential computing. You already know that encryption for data at rest and in transit is very common in our industry. Confidential computing closes that final gap of that three-legged data protection stool, which is data in use protection. While your code and data are actively being processed in the CPU and memory, AMD SEV-SNP or Intel TDX keeps them encrypted in a hardware-based trusted execution environment. The root of trust is in hardware, which means that not even the hypervisor or the host operating system is permitted to see your workload. There are two important takeaways on this slide. One is confidential computing can now protect data in use at scale. And more importantly, with the addition of confidential computing, your data is now protected in all three states of existence: at rest, in transit, and now in use. The protection triangle is now complete. So here's our latest AMD SEV-SNP V6 confidential VM generation. There's 25% better performance over the previous generation, AES 256 encrypted memory, support for online key rotation, scaling up to 96 vCPUs and 672 gigs of RAM, with full confidential Kubernetes and serverless support. These are now generally available across 19 regions, including Azure Government, and very soon these will be available in pretty much all regions and availability zones around the world. This is the direct output of our engineering partnership with AMD and Intel, pushing confidential computing to the point where workloads that require an additional assurance, they can start leveraging these technologies. Confidential VMs deliver the performance and scale you need for production workloads. Alongside our AMD SEV-SNP based offering, we also have Intel TDX V6 confidential VMs that are also now generally available. This gives customer a choice of silicon partners while getting the same hardware-level confidential computing guarantees. The Intel TDX based confidential VM release includes OpenHCL, our open source firmware, which improves transparency into the TCB or the trusted computing base. We've added innovations around accelerated NVMe local storage for high performance workloads, support up to 128 vCPUs and 512 gigs of RAM, and KeyGuard support for Windows environment. Post general availability, we will continue to invest, adding additional features and addressing performance gaps and regional availability as they appear on the roadmap. Today, these VMs are available in West US and West US 3, and more regions will be coming online over time. With both AMD and Intel confidential VMs generally available, Azure enables customers to have a true choice of hardware-based confidential computing platforms across CPU vendors, enabling security guarantees which are similar without any impact to their workloads. And when we think about confidential computing, we look at it across the breadth of silicon, virtual machines, containers, as well as services. This slide shows the breadth of Azure services that are already running on confidential computing. We have Azure Databricks, SQL Always Encrypted, Azure Virtual Desktop, Managed HSM, Azure Attestation Service, Confidential Ledger, and others available, including with Kubernetes with AKS. On the infrastructure side, we have AMD SEV-SNP VMs, as well as Intel TDX VMs, as well as NVIDIA H100 single GPU confidentiality for confidential AI workloads. Multi-GPU support is on the roadmap. The takeaway here is that confidential computing is a broad production ready ecosystem spanning services, containers, and infrastructure. So now let's turn to digital sovereignty. This is where all the technology we've discussed becomes strategically important for governments, regulated industries, and any organization that needs to maintain control over their data and operations in the cloud. Microsoft Sovereign Cloud is our answer, and confidential computing is the technical foundation that makes it work. Confidential computing applies to a variety of use cases. It maps to use cases across many industries. A few of them are here. In financial services, for example, it enables anti money laundering, fraud prevention, secure payment processing, along with protecting proprietary trading algorithms. In healthcare, we see its use in drug development, disease diagnostics, as well as privacy preserving analytics across institutions. In the retail sector, we have seen use cases around clean room collaborations, multi party AI, and advertising targeting with responsible AI principles. Organizations across industries are already running these workloads in production on confidential computing. And at Microsoft, we have a saying of eat your own dog food or drink your own champagne. Microsoft is already one of the world's largest users of its own confidential computing technologies. Services like Entra ID, Azure AI services with inferencing, Azure Databricks, Microsoft Account, the Microsoft Payment Services, and many more are already running on this confidential infrastructure. We rely on confidential computing every day for our most sensitive and mission critical operations. So, when we talk about confidential computing usage inside Microsoft, we are talking about millions of cores running in confidential computing, protecting our most critical internal services. Teams across the company are migrating high value assets, including here, where we are talking about protecting our Entra ID stack, which today is 100% running on confidential computing. Our approach here is that we use confidential computing to protect our own crown jewels and make it production ready to run your most demanding and security sensitive workloads. So, the learnings that we've gotten in our use of confidential computing has translated to how we position our Microsoft Sovereign Cloud, which is our most comprehensive sovereignty principles. It spans three pillars: sovereign public cloud with built in controls, compliance, data boundaries, and in country AI processing; sovereign private cloud with Azure Local for hybrid or disconnected environments; and a sovereign partner ecosystem with local partners who provide domestic hosting and procurement. Sovereignty requirements vary, whether they vary from data residency to full operational independence. This sort of framework gives customers the flexibility to meet their specific needs. Now, Microsoft Sovereign Cloud addresses five critical sovereignty scenarios: regulatory requirements for compliance with local and national standards; sovereign AI processing, where you harness AI while maintaining control over data and model infrastructure; no cloud operator access, keeping Microsoft itself outside the trust boundary; data residency, which is keeping data within defined geographic borders; and business continuity to ensure that operations continue through natural or geopolitical disruptions. So now let's zoom in a little bit on the no cloud operator access. For many customers, this is one of the most critical requirements. This solution is layered. Data encrypted at rest and in transit is already available across Microsoft's network. The addition of confidential computing, keeping data encrypted during processing inside AMD and Intel hardware, and leveraging customer managed keys with giving you full control over end to end encryption. Put together, this means that your data stays private, governed, and under your control, even in a public cloud environment. These capabilities are available today, built on hardware rooted security we've just talked you through. So, when it comes to workload types, we have been working with our customers for some time now. We see four main patterns for sovereign workloads. They range from high sensitivity business applications, such as line of business applications, with strict sovereignty and operator isolation. confidential infrastructure foundations such as identity services and domain controllers running inside confidential VMs as hardened landing zones. Data and analytics workloads such as large-scale compute on Kubernetes backed by confidential nodes, and confidential databases such as platforms using vector databases or traditional databases, protecting data and memory during all lifecycle operations. So now let me share some real-world momentum. G42 in the UAE is using Azure Confidential Computing through a strategic collaboration with Microsoft. KT, based in South Korea, is launching Secure Public Cloud or SPC with the highest data protection for regulated customers. Similar efforts have been underway with Leonardo in Italy and Proximus in Belgium. From the Middle East to Europe to Asia, organizations are choosing digital sovereignty, leveraging confidential computing as their sovereign platform. We have these two videos that we've left here for you to look at over time. They speak directly why these customers chose confidential computing for their sovereignty needs. So with that, thank you so much for spending the time with us today. The partnership between Microsoft and the larger ecosystem is moving faster, broader, and more accessible than before. It is the foundation for digital sovereignty and is available today. I encourage you to try on Azure Confidential VMs for your own workloads. The links on the screen will help you get started. Thank you so much for your time.